Okay, for number 9, the first thing we're going to do is see if we can factor this polynomial. So right away I notice that it has 4 terms. Now anything that has 4 terms, it's always good to see if we are able to factor by grouping. So let me rewrite my polynomial over here. And now I'm going to group my first 2 terms and my last 2 terms and see what I can factor out. Out of my first 2 terms, I can factor out an x squared. So on the inside I have x minus 5. Out of my second 2 terms, I can factor out a negative 9. So then on the inside I'm left with, again, x minus 5. Between this new equation, we have 2 terms that are in common in both, or 2 factors in common in both parts, and that would be x minus 5. So I'll factor x minus 5 out of this expression. So we have x minus 5 times x squared minus 9. Now this isn't quite factored yet because x squared minus 9 is a difference of 2 squares, so we can break down x squared minus 9 into x plus 3 times x minus 3. So now that this is completely factored, I can identify all of my zeros. My first 0 being positive 5, second being negative 3, and third being positive 3. And I would get these zeros from setting each of these factors equal to 0 and then solving. So I'm going to add in my zeros at below the graph down here, and while I talk about each zero's multiplicity. So my first 0 is positive 5 with a multiplicity of positive 1, and I know that because it is raised to the first power. Anything with an odd multiplicity, as you remember, will pass through the x-axis. My second 0 is negative 3, again with a multiplicity of 1, so this will also pass through the x-axis. And my third 0, positive 3, with again the multiplicity of 1, which again, odd degree, will pass through the x-axis. So now I'll graph all 3 of my zeros. I have negative 3, positive 3, and positive 5. Now let's determine our end behavior to see where our graph is coming from and where it's going. So in the end behavior, we're going to determine the left side end behavior and the right side end behavior. So what's happening when our graph is coming from the left and going to the right. So in order to determine what the right side is doing, we need to know what our leading coefficient is. And since our leading coefficient, that is the number in front of this x squared term, x cubed term over here, is a positive 1, then this is positive, which means that the right side of our polynomial function will end going up. Now to determine the left side, we need to know whether this is an odd degree or an even degree polynomial. And since this polynomial is to the third power, that is our highest degree, so it's an odd degree, that means that our right side and left side will be opposites. So if our right side is going up, then the left side is going down. So let's draw in the end behavior on our graph. Now we just need to fill in what's happening in between all of these x-intercepts. One point that we can use to help us determine that is the y-intercept, and in order to find the y-intercept, we plug in 0 for x. So I'm going to evaluate my function for plugging in 0 for x. So when you substitute 0 in for x, we are left with just 45. So my y-intercept is 0, 45. So now if I were to graph this, my graph doesn't even close to go up all the way to 45. So I'm just going to have it extend as if it were going to continue off of this graph. Come from high up on the y-axis. As you can see, I passed through negative 3, came down, passed through positive 3, and again passed through positive 5, and kept going upward. And that is all for this question.